Scraping web pages is an important part of machine learning with natural language processing. This is how you will actually get the text that you want to process and build your corpus or build the training data that you need to train your machine learning algorithm or extract any text that you actually want to perform some machine learning algorithms on. So this is a kind of difficult problem because when you look at any simple web page like this, and if you just go ahead and download it, the corresponding HTML that gets downloaded looks like this. It has a lot of extra things like these tags and divs that you don't really need but are part of the text. These tags and divs are necessary for the HTML to display properly in a browser, but not necessary for you to actually process the text. These are CRUDs that you need to remove. The more complex the web page, the more pictures, other links that it has to go to other sections or other web pages, the more tags or code that particular web page would have. It will have JavaScript sections, other divs and tags, too much that you need to parse and understand before you could extract the relevant text from it. Now this is pretty complex and get hairy pretty easily. Regular expressions are a common way of parsing text. These basically match text patterns and you have to write a specific regular expression for every different pattern of text that you would find and would want to parse. This, as you can understand, could become really error prone and complex very quickly. Beautiful soup. This is just a lifesaver. It's a life-saving Python library that makes text scraping and parsing downloaded HTML text very simple and elegant. You could just go and tell Beautiful Soup with its out-of-the-box functionality to find text which is enclosed within specific tags, find all the links on a particular page, find all the text that's italicized, find things like the title or the body or paragraphs, find the text which is enclosed in p tags, basically paragraphs. Let's say this is an example HTML, some text which is italicized, some which is in bold. There is a link to Google. This is the corresponding HTML which is on the right. So as you can see, it has all the text basically enclosed within the HTML tags, and then there are different tags to separate out the paragraphs, to separate out the heading, to specify the style of the heading, and so on. Beautiful Soup, the first thing it will do is identify a structure within this HTML. It will create a hierarchy. At the top of the hierarchy sits the HTML tag, and just below that there is the body tag, which is clearly the next div within the HTML. So it creates objects called tag objects out of these particular tags, and it creates a hierarchy as well. The HTML tag is the parent and the body tag is the child. Then the body becomes the parent for all these tags, the heading tag, the B tag, and the paragraphs, the P tags, which are all at the same level. So since they are all at the same level within the structure, they are siblings. Now within the first paragraph, there is a link to Google, which is basically enclosed in A tags. So this is a child of the P tag. Now we have some attributes like the style, which specifies the font size, or you could have something like an ID. All of these are attributes of the heading tag, and you can access them using Beautiful Soup. Text is also an attribute that you can access using the Beautiful Soup. So this is the parse tree that Beautiful Soup creates when you create a soup object out of an HTML text. Let's look at some examples now of how we can use Beautiful Soup to parse HTML. We'll create an example HTML to play with. It's very similar to the HTML that we just saw. So let's just go ahead and type in the HTML. We are typing it in as a list because it's just too long to type it as one sentence. And then we will combine all of the words in the list as one string. So notice how we are using a bunch of different tags so that we can see how to extract text from all of these different tags. There is a very similar structure to what we saw. HTML at the top, followed by the heading and the body, which are siblings, and within the body B and para 1 and para 2 are siblings, and para 1 has a link for Google. This particular line, which does the join, will combine all the strings in that list above into one string. We'll instantiate a soup object. So soup is a class which Beautiful Soup provides, which has all of these methods to parse the HTML. So we'll look at what are the methods and member variables of the soup object in a bit. First, let's instantiate a soup object which takes in this HTML. Now this soup has a method called prettify, which allows you to print this HTML in a formatted, easy to read manner. Not just like one big blob of text, but something where you can actually see the structure visually, like this. So as you can see with the indentations, we can very clearly see what the structure of the HTML that we created is. This structure is also understood by the soup object. So we can access the elements at different levels of the hierarchy in the parse tree that the soup object created. As you can see, at the top of the hierarchy is the HTML tag object. Then comes the body. And then within the body, there is a heading and a bold line and 2 paragraphs. So within the body tag, these 4 tags are siblings. So you can refer to one as the sibling of the other. And there is an order as well. So the order is the order in which they appear. The body is the parent of these tags and the HTML tag is the parent of the body tag. You can refer to the HTML tag as the parent of the body tag, soup.body.parent. Each tag also has attributes like name, contents, which is a list of all the tags which are present or components which are present inside that tag, the text of the tag, parent and siblings. Let's see all of these attributes in action. The name attribute is just the name of the tag. So for the HTML tag, HTML is the name. For the body tag, body is the name, and so on. So let's look at that. Soup.html.name gives us HTML. Soup.body.name prints body. Let's look at the text attribute. Basically what this will do is mush together all the text in all the children of that particular tag. It might behave slightly differently for different versions of Beautiful Soup. In some, it might still return the tags which are present inside the text. You can check out how your particular soup version behaves by looking at this particular attribute. Soup.bodyText in my case returned all the text inside the body mushed together in one string. So contents will return a list of children of a particular tag. So for example, for HTML, it will return a list with only one element, but the body tag has 4 children, so it will return a list with 4 elements. There was an error here. We forgot to close the heading tag properly at the right place. We'll go ahead and fix this later. Let's move on. As I said, we could refer to soup.body.parent.name to get the HTML tag. Soup.b.next sibling will get us the sibling at the same level, the next sibling at the same level. You could also use the tag name dot previous sibling. So this basically allowed us to navigate through the tree if we knew which are the tags which are present in that particular tree. But if you wanted to just search for text which is within certain specific tags, or if you wanted to search for tags with certain attributes, for example, all the text which is in bold. So text which is in bold in HTML is always enclosed in B tags. Soup.findAllB will find all the tags which have the text in bold and return a list of these tags. In our case, it will return a list with one element. Now to extract only the text which is in bold, take each element of this list that is returned by findAll and get the text attribute of those particular tags. So bold 0.text will give us the text which is in bold. Okay, now you have all you need to get all the text that is in paragraphs. That is, it's enclosed in p tags, mushed together as one single string. So here's one line of code that will do all that we asked. Soup.findAllP will return a list. p.text for p in that list will give us a list of the text. And then we are doing a join to get one single string. So you can use findAll to search not just for specific tags but also for specific attributes. For example, our second paragraph has the attribute id equals para2. So you could search for the tag which has an id with para2. Since this will return a list, we will get the first element of the list and get the text. This should print the text of para2. So you should be getting the idea by now. Let's find text which has a font size of 20. If you remember, we specified that the heading had a style attribute which specified the font size as 20. Now, Beautiful Soup can also be used to search through CSS. So this is very similar to how you would do that particular search. So soup.findAll style equals font size 20 pixels will give us all the text that is within 20 pixels font. Okay, this is not returning exactly what's expected. It was supposed to return just this is the title. Now I had mentioned earlier that there was a mistake in our HTML. We had not closed the heading tag properly, and that is why this particular error occurred. So let's go fix that. We've closed the heading tag properly, and now when we try to run our code, it's just fine. We just get this is the title. You can also pass in a list of tags or a dictionary to soup.findAll to find all the text which is within particular list of tags. You can also give in a dictionary which specifies each tag to be true. Now this is very useful and super important, so you could pay attention here. How do we find links in the HTML? Now, say you wanted to find all the links on a particular page and then iterate through those links and do something with them. This is what you would have to do. Find the list of all A tags using soup.findAllA. Now, A tags generally refer to links, and they will have an attribute called href, which will be the URL that link will take you to, and the name or the text of the link that actually appears on the web page will be enclosed as well. So for example, we had href equals www.google.com and Google as the link text. So notice how we actually used find instead of findAll. This will just return the first match that it gets. So since our particular page had only one link, this is fine. But if you wanted to get multiple matches or the complete list of links, you can use find all. You could also limit the search by using a limit parameter and saying you want only the first link or the first 10 links on the page. Now you can access the href bit of the A tag as well as the link text of the A tag, and this will get you the URL and the link text separately. You can access the URL by treating href as a key, and you can access the text of that particular tag as well. You can use find to also navigate through the parse tree, that is, say, find parent, find next sibling, find previous sibling, and so on. These work just like find all, but basically treat the starting point as what you specify and then search only within the relevant branches of the tree. So you can also use find next, find all next, find previous, and find all previous to specify a starting point and then search within all the next tags or all the previous tags, whichever is relevant. Let's take an example and see how this works. We're taking only one example, but all the other functions work in a very similar manner. Let's say you want to get the text of the first paragraph after the first occurrence of the text Google. So soup.find text equals Google will specify the starting point as the text Google, and then you find the next p tag after this particular text, which is the para2. There is also a little shortcut to using find all. You can call the tag itself as a function. For example, if you had the body tag, you could call the body tag itself as the function, and you could use it in place of find all with the same arguments. So soup.bodyp will act exactly the same as soup.findAllP, but just within the body tag. There's just a lot of cool things that you can do with Beautiful Soup, but we'll stop here. We will be using it extensively in all our drills for natural language processing as well as for machine learning. The basic takeaway is that Beautiful Soup just makes parsing HTML and XML very intuitive and elegant, and doing the same thing with other methods like using regular expressions is just prone to pulling your hair out. So in most situations, Beautiful Soup will be a lifesaver.